Swayam Prabha. Digital India. Educated India.
Now let's move on. As we discussed, we know that the electrophile that is generated during the reaction is R C triple bond O plus. Okay. So now if we were to sort of, this R can be any alkyl group. So if you start from acetyl chloride, you end up with CH3 C triple bond O plus. If you start with a longer chain carbon, you're going to end up with that corresponding product, okay, or the oxocarbenium ion, right? So now if we were to start with basically H, with R equals H, right? So if I replace this with hydrogen, okay, so then we would get, you would want to generate an intermediate such as this HC triple bond O plus, okay, and this reacts with benzene, and then the product that you would eventually get would be, continues to be Friedel-Crafts acylation, except that you will get benzaldehyde, okay. So this reaction can be conducted. This reaction is known as a formylation reaction. I'm just going to write it down so that you understand this. So FORMYLATION. It's called a formylation reaction. And this formylation reaction can actually be carried out under some conditions. Okay, so the conditions are as follows. Basically, we need to generate HC triple bond O plus, and this can be done by the following conditions, which is reaction of HCl plus carbon monoxide. I think many of you know carbon monoxide, and plus a Lewis acid, which is AlCl3, and you also need CuCl, okay. And this is usually a reversible reaction. So you will get HC triple bond O plus and AlCl4 minus, which is a familiar reagent for us now. And the conditions correspond to what is known as the Gattermann-Koch reaction, okay. So the Gattermann-Koch reaction is nothing but the reaction of benzene with these reagents as shown here, which is HCl, carbon monoxide, aluminum chloride in the presence of copper chloride, and the product that is formed is actually the formylated benzene, which is the following, which is basically benzaldehyde. Okay, so Gattermann-Koch or Gattermann-Koch reaction is actually a modified Friedel-Crafts reaction, and it produces aldehydes on aromatic compounds. Okay. Now there's a variation of this reaction, which is basically instead of using carbon monoxide, you could also use HCN, which is hydrogen cyanide. Okay. So HCN is basically essentially C triple bond N H, and if you recall, the intermediate that we were looking at was HC triple bond O. Okay, so if you see that these are actually isoelectronic, and so you can use HCN for this same formylation reaction, and the reaction conditions that can be used are HCN in the presence of an acid, and in the presence of, you can use HCl and a Lewis acid, and it's going to give you the product. Okay, So the mechanism that we're looking at is basically the reaction of benzene plus C triple bond N H. And if you're doing this reaction in the presence of a strong acid, then what can happen is this attacks and the C triple bond N can break, and it gives you the intermediate C double bond N H, and there's a hydrogen that remains over here, right? And you can generate a positive charge as always in electrophilic aromatic substitution, and this is the intermediate that's going to be formed. Okay, and subsequent loss of proton, this can be lost, and then you have hydrolysis around the C double bond N. It's going to give you the aldehyde. Okay, so these are some modified conditions that can be used to generate aldehydes and and even ketones for that matter, and these are collectively known as Gattermann reaction. All right, now let's discuss the couple of problems that we told during the class. So this has been done, as I mentioned earlier, to make sure that you guys listen to the lectures. So the first problem that we looked at was when the reaction of benzene in the presence of Br2 really doesn't happen, and if you add a small amount of pyridine, it actually gives you the product, which is bromobenzene, right? So the question that we asked was, what is the mechanism? How do you explain this observation? Okay, so pyridine, as you know, is actually a base, right? So it is aromatic, but the electrons that are present here are actually quite basic on the nitrogen. And so you can imagine that Br, which is quite familiar to us, that it's Br2 can actually heterolytically cleave to give Br minus. So you can think about a similar reaction where this attacks, and the attack actually produces Br minus and Br plus. Okay, so the Br plus is going to be in the form of pyridinium ion. So your reaction is going to be in the following way. So it is going to form NBr, and pyridine actually acquires a positive charge, and it produces Br minus as a byproduct. Okay, now this pyridine complex, brominated pyridine complex, is actually quite reactive, and so you can imagine that benzene is now, it's quite favorable for benzene to react and give you a pyridine as the byproduct and give you the same complex that we normally are used to during bromination. So it's going to give you BrH and this as the product, and it will give you pyridine as the byproduct. Okay, so now as you can see, pyridine becomes available for further reaction, and therefore it is actually catalytic. Okay, and this complex can then further break down and give you the product, which is the bromobenzene. Okay, now let's move on to the next problem, which is to do with the Friedel-Crafts acylation reaction. So here the question that we had asked was the following compound, which is, what is the product that is formed when you expose this compound to AlCl3? Okay, so I'm just going to redraw the compound structure here, and just to be clear, let's number it 1, 2, 3, 4, and so this was the compound, and the question that has been asked is, what is the product that is formed? Okay, so in order to address this question, let's look at what AlCl3 could do in the presence of an acid chloride. All right, so normally when we look at an acid chloride and aluminum chloride, we know that the following intermediate is going to be formed. Okay, so therefore if you consider this scenario, so you're going to get the benzene ring would remain the way it is, right? And then you have 1, 2, 3, 4, and if this is the carbon and the acid chloride that's going to react, and it's going to kick out chloride ion. Then the product or the intermediate that you're going to get is C triple bond O plus. Okay, just to be sure, let us now just renumber this 1, 2, 3, 4, and then there's the benzene ring. So numbering wise we are fine. So this is going to be the intermediate that is formed. Okay, now what can this intermediate do? Right, there are many things that the intermediate can do. One is, if there is some nucleophile present, it's going to react with that nucleophile and produce the product. But in this case, I don't see any other nucleophile being present here. So the other alternative is that it can do an intermolecular reaction. And now this intermolecular reaction of course can happen. And the intermolecular reaction could be the reaction of the benzene ring. But what is also possible is an intramolecular reaction. And so the way in which the intramolecular reaction can occur is in the following way. So this is the electrophile and it attacks on this carbon, and then you're going to have electrons being pushed over there. Okay, so let's now draw out this product that we are going to look at. Now what I'll do is I'm just going to number this so that it becomes easy for us to follow. So this carbon that I'm highlighting here, okay, you can see that this bond over here is going to react and it's going to give you the product. So let me draw out the product as shown here. So let's number this as number 5 and number 6. So we redraw the benzene ring, and so there's going to be carbon number 5 and then there's carbon number 6. They're going to remain intact, and just to be clear, I'm just going to highlight this over here, and the rest of the molecule is going to be the same as far as the benzene ring is concerned. But now in this new ring, we have already determined that it's going to be a 6-membered ring, right? And so in order to understand the 6-membered ring, we're going to see the numbering as we have done previously. So this is going to be carbon 4, this is carbon 3, this is carbon 2, and this is carbon number 1. Okay, and carbon number 1 actually has the double bond O on it, right? So far we are doing fine. Now we need to make sure that the product is written out correctly. And so once this bond over here breaks, then you're going to form, there's going to be a hydrogen that remains here intact. So this hydrogen is going to be intact, and there's going to be a positive charge over here, right? So this is going to be the structure that is going to be formed. And now if we can propose that there's going to be a loss of H plus to restore aromaticity, then the likely product that would be formed would be the following, right? So if you stick to the same sort of numbering, this is C double bond O, and this is number 5, this is number 6, 4, 3, 2, 1. Okay, so this is likely the product that is going to be formed during this reaction. Okay, now I want you all to go back and look at the M by Z ratio of this molecule, and you should be able to get 146 as the M by Z ratio that you would predict.